What is a galvanic cell, and how do we use cell notation to describe them? A galvanic cell is one where a redox reaction is split between two half cells and can be used to power a circuit. So let's consider this situation where we have two half cells, and in one cell we have solid zinc, and in the other cell we have solid copper. The zinc is in a solution of zinc sulfate, and the copper is in a solution of copper sulfate. If we want to predict how these reactions are going to go, we go to our reference table, we look up their reduction potentials, and we see that copper is more likely to reduce. So its half reaction is going to be copper 2 plus 2 electrons is going to give us solid copper. This is a reduction because a reduction in oxidation state occurs, or for our ions, a reduction in charge. So we go from having a copper with a 2 plus charge to a solid copper with a plus 0 charge. Our charge has been reduced. Our oxidation state has changed from 2 to 0. And this was done by gaining electrons. So a reduction is a reduction in charge by gaining electrons, because our electrons have a negative charge, and so they cause our charge, our oxidation state, to go down. So this cell where our copper is going to be where reduction occurs. And since redox reactions are called that because they come in pairs, you can't have reduction without having oxidation, that means our zinc cell must be where oxidation is occurring. And that means our reaction for zinc is going to be solid zinc is going to give us zinc 2 plus ions plus 2 electrons. And this is going to be an oxidation because now we have a zinc with a 0 charge becoming a zinc with a 2 plus charge. So our oxidation state is going from 0 to 2. It is increasing, it is oxidizing, and it's doing that by losing electrons. Or the way we can remember this is oil rig. Oxidation is the loss of electrons, and reduction is the gain. So now that we know what's happening in each cell, what the half reactions are on either side, we can see that our zinc is losing electrons and our copper is gaining electrons. So our zinc is going to give those electrons to the copper that's going to take them. But it can't do that right now because they're in two separate beakers. They're in two different half cells. So in order to form our entire galvanic cell, we have to connect them together. And so we're going to draw a wire from one cell, from the zinc to the copper. And we're also going to include a salt bridge. That salt bridge is going to contain an inert salt, something like potassium sulfate, which is going to maintain contact between the two beakers, balance out the charge buildup, and complete the circuit. And now that we have a path that our electrons can travel, it's going to allow the zinc to donate electrons to our copper, and that as those electrons are traveling from our zinc to our copper, it can be used to power something like a light bulb. Since our electrons are being drawn to the copper, they're moving towards our copper, that's going to be our positive pole. Since opposites attract, the electrons are going to be attracted to a positive pole. And since zinc is giving up our electrons, since they're traveling away from the zinc, they're going to be traveling away from our negative pole because like charges will repel. And so we're going to call our positive side our cathode, because it's positive, like a cation is positive, and we're going to call our negative side our anode, because it's negative, like an anion. And we notice that on our right side, our cathode is our reduction and our anode is our oxidation. And that's always going to be the case. They're always going to be paired together. And the way you can remember that is you're looking for an ox and a red cat. So an anode is always going to be where oxidation occurs, and a cathode is always going to be where reduction occurs. And now that we know all the parts of our galvanic cell, we can put it into cell notation. We're going to start with the anode, because A is first alphabetically, so we'll start with our anode, and then we'll separate each component with a vertical bar, and each half cell with 2 vertical bars. So our anode is going to be solid zinc, bar, zinc sulfate in solution, and that's connected to another cell which has copper sulfate in solution, turning into solid copper. Where sometimes we'll see cell notation where just the ions are used. So we'll have solid zinc is being oxidized to zinc ions in solution, and that's attached to copper ions in solution being reduced to solid copper. And that's it. That's our parts of a galvanic cell and how we can use cell notation to describe them.